Today's lesson is called Scatter Plots and Their Trends. So a scatter plot is a graph of various points that shows the relationship between two sets of data or variables, x and y. So two sets of data means that we're going to have an x and a y. The x will be the independent variable. If you are the independent variable, that means you do not rely on any other data. So does not, and we'll underline that, rely on other data. If you are a dependent variable, that means you do depend, like right in the word, you depend on something else. So we're going to say that this relies on the independent variable. So below you're going to see a table of values for temperature in Fahrenheit and ice cream sold. And if we go ahead and scroll down some more here, you're going to see the full scatter plot that was created from this data. So you can now see that temperature is on the x-axis. So I'm going to put x here so we're aware that that matches up, which means that's the independent variable. It does not rely on the other data, the temperature. And then on the y-axis, you have ice cream sold, so that's your y variable. And if we go back up, remember that's the dependent variable. It relies on the independent variable, right? So the ice cream sold depends on what the temperature is outside. So what I'd like you to do is pause the video for just a minute and answer the question that you see underneath the graph. Is there a relationship between temperature and ice cream sold, and how can we describe this pattern? So at this time, pause the video and try the question, and then resume the video when you're ready to check. So is there a relationship between temperature and ice cream sold? I would say yes. How can we describe this pattern? Well, if I look at this, it seems to be that my scattered plots are generally increasing. As my x is going up, my y is going up. So I'm going to write that in terms of our situation. Our x is temperature and our y is ice cream. So I'm going to say as the temperature increases, the amount of ice cream sold also increases. So that's describing the relationship. And overall, we'll talk about all the different ways we can describe scatter plots and the words that we use to do that. So on the next page, so scatter plots are described by patterns and deviations from the pattern. So that means what you see is a general pattern, and there's words you can use to describe it, and deviations means that sometimes there are things that are different from the pattern. We're going to talk about all of those. So the first way that you're going to describe a scatter plot is by direction. The direction of the relationship can be either positive, negative, or neither. So if we look at our two most common ones, we have that a positive relationship means that as one variable is increasing, the other one is also increasing. So that's very similar to the one we just looked at with temperature and ice cream. So if I look over at my three pictures of scatter plots, this one in the top left would be a positive, what we call association. You can see as x is going up, y is also going up. We also can have a negative relationship, which means as one variable increases, the other variable decreases. So here, think of it as x going up and y going up. This one is x going up, but y is coming down. So that's actually the next scatter plot that you see to the right. As my x's are increasing, my y values are coming down. So this one would be a negative association. And then lastly, you can actually have it where it's neither. So if you look at that bottom scatter plot in this group of 3, the points are so completely scattered that I cannot find an overall direction of positive or negative. In addition to this, I want to add in a little note on the side. I use the word association, but you might also see the word relationship. Or correlation. So we'll write relationship or correlation could also be used. So that all describes the direction of the scatter plot. Now we're going to move on to form. Form. The form of the relationship is its general shape. So we have 2 options here. The first one is linear form. Linear has the word line in it, so it's referring to something that looks closest to a line. So linear form is data points that are scattered about a line. If you look at our pictures, you can see the one on the left would be considered linear form. They take the general shape of a straight line. If you're not a linear form, you are nonlinear form. And that's where the data points are scattered about a smooth curve. So if you look at the scatter plot on the right, you can see that the points are taking more of a curved pattern. So this one would be an example of nonlinear form. So far we have 2 things that we should be describing our scatter plots with. We always want to say which direction. We're going to add to that now saying which form. And then we're going to move on and have a discussion about strength. The strength of the relationship is a description of how closely the data follows the form of the relationship. So the closer the points are to the form, the strength or the stronger the relationship will be. So if I look at these 2 pictures of scatter plots, we see that they are linear forms, okay? Because the data generally looks like a straight line. And if I'm comparing these 2, the one on the left, you can see that the points are much they're tighter packed to that straight line. The distances they are away from that line are smaller than the one that you're seeing on the right where they're more scattered. Both of them are still making the shape of a line, but the left one, they're closer to the form of a line. The right one, it's more spread out. So we call one strong and we call one weak. So this one would be strong linear. And this one would be weak linear. Now, obviously, this is kind of a scale of things. Sometimes you could almost even have moderate somewhere in the middle. But for right now, we're really thinking about, does this look like a strong relationship or a weak one? So again, now we can describe the direction, the form, and the strength. Now let's discuss outliers. So outliers, we're going to fill in here, are points that deviate from the pattern of the relationship. So if we go back and look at our scatter plot with ice cream sold and temperature, you can see we've added in a line. So we're going to talk about that at the same time. This is line of best fit, and it's a line that follows the trend in the data. So since we knew it was an overall positive trend as X increases, Y increases, a line of best fit has been drawn on the scatter plot to show the general trend of the data. If you take a look at this line, the line is in the middle of the data and has about the same number of points above and below. So you're trying to put it in the middle of the data to show the general trend. It can hit some points. It could also not hit any points that are actually data points. It's more about showing the general trend. So then if I go back to outliers, outliers are points that deviate from the pattern of the relationship. So if I'm looking at this overall scatter plot, can you tell that there's one that's just kind of off the path of the rest? It's this one right here. This would be considered an outlier. And again, it's because it deviates from the overall general pattern of our scatter plot. So now that we have learned all the ways that we can describe scatter plots, what I'd like you to do is, again, pause the video and revisit our description of what we wrote for our scatter plot on temperature and ice cream sold. And what I'd like you to do now is describe it again, but go back and use all of the new vocabulary that you've learned to do that. So if you would please pause the video. You can resume the video when you're ready to check your answers. All right, so if I was going to go back and hit all of the points we talked about, first we learned direction. We want to say if it's going in a positive, negative, or neither direction. So for us, as our x is going up, our y is also going up. So this is definitely a positive relationship. After that, we learned about form. So it's either going to be looking like a line or looking like a curve. So if we have here looking like a line, that means it's linear. Then we want to discuss the strength. How close are they to the actual line? And if I'm looking at this, we have several that are actually touching the line. And with the exception of the outlier, it looks like a pretty strong relationship. So we'll say strong. And then with, the last thing we want to always consider, outliers, we'll say with one outlier. And that concludes our lesson on scatter plots and their trends.